Hello everyone, my name is Alexander. The topic for the lesson is on capacitor and capacitance. At the end of this lesson, you should be able to define a capacitor, explain the term capacitance. Here we have different form of capacitor. These two is an electrolytic capacitor on which we can get the polarity, positive and negative. This is a capacitor that we cannot differentiate or try to identify the positive and the negative part of it. But these are all capacitors in different form. The basic idea of the capacitor is that we represent a capacitor by the symbol here generally, the symbol of a capacitor. Capacitors store electric charge. Yeah, that's two plates. One plate is connected to the voltage source, which is charged positively Q, and the other to the negative, which is charged negatively Q. There's an insulator there, which is dielectric substance. We define a capacitor as a device. A capacitor is a device for storing electric charges or for storing electricity. It consists essentially of two conductor metal plate carrying opposite charges. The metal plates are separated a small distance d by an insulator. On the previous diagram, this shows what we are trying to say. This is the distance between the two plates, the material between the two plates, known as dielectric substance. It's an insulator. And this has an effect to increase or decrease the capacitance of the capacitor. Capacitance of a capacitor, the capacitance of a capacitor is defined as the ratio of the charge on either plates of the capacitor, that plates of the conductor, to the potential difference between the plates. That signifies C is equals to Q over V. This C, which is Q over V. Now here the capacitance depends on the ratio of these two parameters, the charge and the voltage. And here we can say that we have a constant system. If the voltage increases, the capacitance decreases here. And now we say that the capacitance is directly proportional to V. Likewise, the capacitance here is directly proportional to Q. Capacitance is measured in farad. General, that is the SI unit, farad, measured in farad. We have other units such as microfarad. Microfarad, the symbol here, micro, signify 10 raised to the minus 6. Example, if you have a capacitance of 3 microfarad, it means that this is 3 times 10 raised to the minus 6 in farad. Then we also have other unit known as picofarad. The pico signify 10 raised to the minus 12. If you have an example of a capacitor that have a capacitance of 16 picofarad, these can be 10 raised to the minus 12 farad. There's other unit known as the nanofarad. The nanofarad capacitor can also be measured in that. If you have a capacitance of 10 nanofarad, that means this is 10 times 10 raised to the minus 9 farad. So the nano here signifies 10 raised to the minus 9. And then we have the millifarad. Capacitor can also measure in millifarad. If you have the milli, signify 10 raised to the minus 3. If you have a capacitance given as 4 millifarad, I mean that is 4 times 10 raised to the minus 3 farad. The value of the capacitance depends on the size, shape, distance separating the two plates, and also on the nature of the material that separates them, or the common area of the plates. Now, depending on the size of the capacitor and the shape, that affects the capacitance of the capacitor. A power plate capacitor is given by this expression here, C, given by the expression that C is the permittivity of the medium between the plates multiplied with the cross-sectional area and the distance of separation between the plates. This can be explained in terms, if I have a power plate capacitor and this plate is connected to a source of voltage. This is positive and negative. With this end, this will be charged positively, and this will be charged negatively. And this is the distance of separation between that separated two plates. The medium here is what we know as the permittivity of the material. It can be air or insulator. And the capacitance here is given by the expression. That means this is the physical parameter in terms of the power plate capacitor. It is across the area of the plates, and this is the distance that separates two plates. And the capacitance depends on this parameter. In terms of the area, the capacitance increases with the area. The area increases, the capacitor also increases. In terms of the distance that separates the two plates, that's D. When the distance increases, the capacitance drop in value decreases. So C is inversely proportional to the distance. If you want to increase the capacitance, that means smaller distance is required to have capacitance, the value of the capacitance increase in value. For example, we have an example here. If you have a power plate capacitor capacitance, the capacitance is given as 600 microfarad and a potential difference V of 2000 volts between the calculated charge. Yeah, we are looking for the charge on either plates of the capacitor. Capacitance is the ratio of the charge to the voltage between the plates. And since we are looking for the charge becomes capacitance multiplied with the voltage. That is 600. Remember, this is micro. That is 10 raised to the power minus 6 times 2000 volts. When you do that, that will give us 1.2 coulomb. The unit of charge is the coulomb, 1.2 coulomb. That is the unit of charge. Here's another example. We have example says a power plate capacitor of area. The area is given. The area is 10 cm square. And this is not the SI unit. You have to convert this to the SI unit. That is 1 cm cube is equal to 10 raised to the power minus 4 meter square. That is 10 times 10 raised to the power minus 4 meter square. Let's convert that. So a power plate capacitor of area 10 cm square in vacuum has a capacitance. The capacitance, yes, C is given as 10 raised to the power minus 2 microfarad. We have to convert that 10 raised to the power minus 2 because of this micro here times 10 raised to the power minus 6 farad. What's the distance between the plates? We're looking for D. The permittivity of the medium is given to us, which is 9 times 10 raised to the power minus 12 farad per meter. And once again, the capacitance is expressed as C is equals to the permittivity multiplied with the cross-sectional area and the distance of separation between the plates. This distance is what we are looking for. D, make it a subject of formula. You will have this expression. You substitute the value, that is 9 times 10 raised to the power minus 12 and the area is 10 times 10 to the power minus 14 all over the capacitance is 10 raised to the power 2 times 10 to the power minus 6. If we use the calculator and calculate that, we end up having 9 times 10 raised to the power minus 7 meters. That's the distance of separation between the two plates. Thank you for watching. Thank you.